Good day to you, and welcome to Fascinating. I'm your host, Rick, from planet Vulcan. My ongoing mission on planet Earth to search for signs of intelligence and to encourage its spread. In this essay, we turn our attention to the late 20th century Biosphere 2 project, also known as Biodome. This project was an attempt to create a closed ecological system that could support life independently of the external environment. It was inspired in large degree by the aim of furthering space travel and colonization. From the point of view of the fascinating series, the course of the experiment and its ultimate failure provide an object lesson in the limits of intelligent design in general. Let's begin by having a look at the history of the project. The visionary behind the Biodome project was John P. Allen, an engineer who pioneered a systems approach to ecological management. Allen, along with a group of ecologists, engineers, and futurists, founded the Institute of Ecotechnics in the 1970s to explore innovative solutions to environmental and ecological challenges. The Biodome project was conceived of as a large-scale, practical application of their ideas. The team envisioned a facility that would not only replicate natural ecosystems, but also serve as a model for sustainable living and resource management. They attempted to design a facility that could replicate various biomes, including rainforests, deserts, and oceans, within a single structure. The aim was to create a balanced and self-sustaining ecosystem, and they reasoned that this would require a careful selection of flora and fauna, control of atmospheric conditions, and water and nutrient cycling systems. The structure would need to be virtually airtight to ensure the integrity of the enclosed environment. They developed glass panels which maximized natural light while maintaining thermal insulation, and they built in heating, ventilation, and air conditioning systems which were designed to regulate temperature and humidity. They chose a site in the Arizona desert, providing ample sunlight and space. Construction began in the late 1980s, and the facility, covering just over 3 acres, was completed in 1991. The dome itself was constructed of steel frames and glass panels, forming linked geodesic structures. In the early stages of the experiment, the designed ecosystems began to function as intended, with plants photosynthesizing, animals finding their niches, and microorganisms playing their roles in nutrient cycling. But as time went on, unforeseen challenges began to emerge. One of the most significant issues was the buildup of carbon dioxide levels, which eventually exceeded safe thresholds. Decomposition of dead organic matter and the respiration of living organisms together were producing more carbon dioxide than could be absorbed by the plants. Another major challenge was the health and well-being of the human inhabitants. The initial team of biospherians faced various health issues, including nutrient deficiencies and psychological stress. Over time, the ecological imbalances within the biodome became more pronounced. Certain species began to dominate, while others struggled to survive. For example, the insect populations, crucial for pollination and pest control, experienced significant fluctuations that disrupted plant growth and reproduction. Additionally, microbial populations in the soil and water systems behaved unpredictably, affecting nutrient cycling and water quality. The dome developed leaks over time. These leaks not only allowed outside air to enter, disrupting the controlled conditions, but also made it difficult to maintain stable temperature and humidity levels. Technical failures in the HVAC and water cycling systems further compounded these issues. In 1994, they terminated the experiment when it became clear that it had failed irretrievably, and they then opened the structure to the external environment. I asked my chatbot what were the lessons that could be taken from the course of the project and its ultimate failure. Here is how the bot replied. The failure of the Biodome project provided valuable lessons for future endeavors in closed ecological systems and space colonization. One of the key takeaways was the complexity of creating a self-sustaining ecosystem. The interactions between species, nutrient cycles, and atmospheric conditions were far more intricate than initially anticipated. This highlighted the need for more comprehensive models and simulations before embarking on such ambitious projects, and more rigorous planning. Now let's see what we can make of this project when we look at it from the perspective of evolutionary thinking, rather than from the perspective of intelligent design thinking revealed in the conception of the experiment and in the consensus reaction to its failure as revealed in the chatbot reply. The design team put together by the Ecotechnics Institute believed that the proper goal was to replicate the environment that had evolved on planet Earth. But might such a thing as replication actually be achievable with more refined methods? Could the ability to foresee and manage a greater degree of complexity perhaps lead to a successful outcome? We believe that the probability of successfully implementing a designed and controlled system is vanishingly small, simply because of the fundamental unpredictability of natural processes, a topic this podcast has addressed in the essay on fractal geometry, which I invite you to listen to if you have not already done so. And the reasoning that leads to this conclusion starts with the fact that the source of the complexity in nature is the non-linear character of many of the dynamical relationships in the natural world, which frequently results in sensitive dependence on initial conditions, also known as the butterfly effect. In short, the conclusion we are led to is that it is only by employing natural processes that we can possibly create a sustainable ecosystem, and that we cannot even expect to know what it will look like until the evolution occurs. Contrast this with the dominant way of thinking on planet Earth, where step one is to visualize the outcome and then try to force it into being. If anyone seriously expects to succeed in producing a sustainable ecosystem, they must start by giving up the hope that they will be able to replicate a system that has already evolved. The only approach that can possibly succeed in producing a functioning, independent ecosystem is to let evolution happen instead of trying to replace it with something designed. Only nature can manage this level of complexity. Earthlings need to conceive of themselves as cultivators and not as architects when it comes to ecosystems, just as they must when the subject is socioeconomic systems. I invite you to have a listen to the next fascinating podcast and have a look at the next video on our YouTube channel, Fascinating at Prego Donata. If you find the lessons from nature in these podcasts personally valuable, please recommend it to your friends. Theme music, Helium, with thanks to Track Tribe. Live long and prosper. Savor your experiences. Treasure your memories. Anticipate a happy and rewarding future. And respect nature's wisdom.